I am going to give a small demo on LCR circuit, series and parallel, and the instruments I am going to show you here. This instrument is called as the frequency generator, and this instrument is for L, C and R connected, and this is the instrument box, and here there is an ammeter also. These we are going to call it as an apparatus. Now here in this case I am going to first tell you something about the frequency generator. The frequency generator varies from 100 to some 10,000 range, and here we are going to connect it for the sinusoidal, and I am going to keep the voltage at 20 volts. And here there is an inductor in this instrument. This inductor will be taken in this series circuit 1. The series refers to the end-to-end terms are connected to the other one. So one second end of the inductor will be connected to the first end of the capacitor, and the second end of the capacitor will be connected to the first end of the resistance, and all these three are connected in series. Here there is an ammeter to measure the current. This is called as milliammeter. So here is the ammeter. There is one more circuit here. This is for the parallel circuit that I am going to deal this later on. Now I am just connecting the connections. You can just watch the connection. Here there are two terminals. These two terminals we are going to connect it to the variable source. So these two terminals is connected to the variable source. Now I am going to connect it to the milliammeter box. Two wires we are taking and connecting it to the milliammeter box. The next two wires I am going to connect it to the inductor. So these two are the inductor points. So I am connecting a bigger wire here. So one more wire we are going to connect it. So this being the inductor. Inductor refers to it produces a self EMF in the circuit. The next one is the capacitance. Two wires from the capacitance connected to a capacitance box. And another one I am connecting it to the resistance. So two wires from the resistance connected to the resistance box. This being the LCR circuit in series. So in this, if I switch on the circuit, you can see that there will be a minimum amount of current. We can see here. This, you can see the current. This is the minimum amount of current you can see. Okay. This is the minimum amount of current we are going to see here. You can watch. Now I am varying this frequency from 100 to the maximum one. I just vary from 100, and you can see this for 100 the value has changed. Then I am keeping this for 500 and noting down the reading. Then I am going for 700. Then I am going to 900. I will come back to again 1000 by shifting the this pointer. So this is now 1000. I will move now 100 division so that I can get the peak value. 1100, 1200, 1300, 1400, 1500 up to the peak value I get. I will get a peak value, and then after that start decreasing it. So I can move on up to 8500. So it keeps on decreasing the value. So it has started from 0.63 and now it will come down to that much value. Okay. So now after this I am going to plot this in the graph. We can see the tabular column here. This is the circuit diagram which I am using. This is a circuit diagram which I have connected, which you see in the instrument. So this is the circuit diagram, and then there is a tabular column here. This tabular column consists of 3 columns. Number 1 will be the frequency variable. I'll start with 100, 300, 500, 700, and the next column will be milliammeter in series. So for 100, what is the corresponding reading, and then for 300, what is the corresponding reading? You can come up to the maximum value. So then this I am going to plot the graph. So the graph will be plotted. The graph is as shown here. The frequency is taken along the x-axis and the current is taken along the y-axis. So you can see that the curve gradually increases, reaches saturation point, and then start decreasing it. So where do you get the maximum current? That I am going to call it as the maximum current. And then from that value of the current, I am going to divide this by root 2, 1.41, so that I can get the RMS value. From that I am going to cut the curve. If I cut the curve, I am getting the 2 points here. Now number 1 is called F1 and the other number is F2. So difference of these two, F1 difference F2, will be giving me the bandwidth. Okay, and the peak value of this, the peak value of the frequency what I am getting, I am going to call it as the FR, resonating frequency. So I can calculate about 3 things with the help of this. Number 1 is the bandwidth, number 2 is quality factor, and number 3 is the inductor value. So the formula will be, here I am going to show you that. So the formula for the quality factor will be FR divided by F1 difference F2. That is the quality factor. And then for the bandwidth, F1 difference F2, that will be the bandwidth. That gives you the difference will be bandwidth. Then you can calculate inductor. Inductor value can be calculated using the formula L subscript S is equal to 1 upon 4 pi square into CS into the F0 square, FR square. So pi is 3.14. So I am going to just use it 1 upon 3.14 square into the this capacitor which I am using here is 0.1 microfarad. So I can write it as equal to 0.1 into 10 to the power minus 6 into the frequency square. Frequency I am getting at the maximum will be at 1500. So 1500 square, and this if I write into 4, that gives me the inductor value. So which will come around 0.703 Henry I am going to get this. Then again I am going to go complete for the parallel circuit. So in the parallel circuit, again what I do will be, I am connecting the inductor and the capacitance in parallel. So both this I am connecting the wires, I am showing the circuit diagram. You can see now. So capacitance is connected parallel and inductor is also connected parallel. Now you can see the current. The current is being the maximum current. You can see. See, this is a maximum current you are going to get when you connect it in parallel circuit. So I will start with the frequency varying from 100, and then I will go for 500, 300, then I go for 500, 700, 900, and then again I will come back and move on this button to the fourth one. That fourth button will varies from 1000. So I will move 1000, 1100, 1200 up to some 1500. I will be getting the least value, the minimum value I am getting, and that after that again, see, this is the minimum value I am getting. this is the minimum value we get. Afterwards again you see it is increasing it. So it increases, and you can see that. The same thing I am going to register in my tabular column. The tabular column, again you can see the frequency for 100, what is the current I am getting it, and for 300 what is the current. So I keep on writing this and complete up to this. So this again I am going to tabulate in the tabular column. After tabulating this, I am going to plot the graph. The graph is as shown here. The graph is as shown here. The frequency is taken along the x-axis and current is taken along the y-axis. Here I am getting exactly reverse of the series circuit. I will be getting a reverse side, that is parabola. I am, instead of getting the maximum current here, I will be getting the minimum current. So that minimum current is maintained as I minimum. Instead of dividing by root 2, here I am multiplying with root 2. So whatever the minimum value I am getting, I am multiplying with root 2, and that gives me some value. There I am cutting the curve. If I cut the curve, I am getting F1 and F2 two difference points. So F1 and F2 difference gives me the bandwidth, and I am going to calculate the bandwidth. Similarly, I can just calculate the quality factor also. Quality factor is nothing but equal to, Q is equal to FR divided by F1 difference F2. Whichever is greater, that you can subtract. Okay. So after getting this, again you can calculate about the inductor value. So inductor formula once again, L subscript P. L subscript P is equal to 1 upon 4 pi square into Cp divided by Cp into Fr square. Once again, 1 divided by 4 is constant, into pi is 3.14, into Cp is 0.1 into 10 to the power minus 6, into the resonating frequency. Again I am getting lowest frequency, lowest current, and that frequency is 1500. So once again I will keep the same value, and if I just calculate, I am getting about the same inductor value, because I have not changed the inductance, the same I should get it. So that is around 703 Henry I am getting it, millihenry. So this is a graph we are going to get this. Okay. So you can do this experiment for different values. Okay. Thank you.